Welcome to lesson 4.14, identify points on a function. Our objective for today, you guessed it, we're going to identify points that lie on the function. So the first thing we have to do is write the equation of the line and graph it. So this is a review, right? We're taking a table and we have to find two things for our line, our slope and our y-intercept. So we have y equals mx plus b is the slope-intercept form of the line. So here, remember, I have to do, for my slope m, I have to do my change in y over my change in x. So my change in y, I'm going from 0 to -4. That's going down 4. So I'm going to go down 4 over my change in x. From -2 to 0, I'm going up 2. So my slope is -4 over 2. Well, that's the same thing as -2. So our slope is -2. Which means our m is -2. Now our y-intercept, remember, that's b, and that's when x is 0. So when x is 0, y is -4. So b, we have -4 as our y-intercept. So our equation that we have is y equals m, which is -2x, plus b, and b is -4. Okay? So now we need to graph this line. So if we're looking at this, we're going to start at our y-intercept. That's our initial value, -4. So that's where it crosses the y-axis, remember? And then because our slope is -2, I can rewrite that as -2 over 1. So from this point, because it's negative, I have to go down 1, 2, to the right 1, and then connect that point. So I have this point here, and if I keep going, I'm going to go over there like that. So now I want you to think to yourself, what points lie on this line? Well, looking here at the table, we see that the point -2, 0, right? The ordered pair -2, 0 lies on the line. So you know what? That means that Miss Wall did not draw her line very well. Because if I did draw it correctly, it would go through this point because it's on the table. Here we have 0, -4, well, that's already a point that we have. And then 2, -8 is off of our page. So now this was our third point. We can see it looks a little nicer. Now that's the equation of my line, right? So notice the points on the line. I have -2, 0 on my line, 0, -4. I also have the point 1, -6 that lies on the line. Right? And then finally 2, -8. So I want you to think to yourself, what is a point that doesn't lie on the line? Pick any point you want. Go ahead. Take a minute. Think about it. Well, Miss Wall, this point doesn't lie on the line. No way. It's way over here in quadrant 1. Our line doesn't even go through that quadrant, right? So this point, 1, 4, doesn't lie on the line. What about this point? 6, -5. That doesn't lie on the line, right? So these are all points that don't lie on our line. It's interesting to see. And it's going to help us in the long run. So flip the page. This next part says graph the equation 2x plus y equals 6. So what we have to do first is get y all by itself, remember, because we need it in y equals mx plus b form. Right now we're adding 2x to it, so the opposite would be to subtract 2x from both sides. So we get y equals -2x plus 6. So now let's graph that. So our y-intercept is 6. So we're going to be right up here where it crosses the y-axis at 6. And our slope is -2. Now remember, we can write that as -2 over 1. So because our slope is -2 over 1, we're going to go down 1, 2 to the right 1. Here we're going to go down 1, 2 to the right 1. 1, 2 to the right 1. And I'm going to connect these points. So looking at this, it says, what points lie on the function? Well, what points did we graph there? Well, remember, our y-intercept is 6. So that means that our x value is 0, 6 for our y-intercept. So that point certainly lies on there. The next point we have graphed is 1, 4. So 1, 4 lies on there. We also have the point 2, 2 that we graphed. And we have the point 3, 0 that we have as well. So those are all points that lie on our function. But what are 2 points that don't lie on the function? Well, take a minute. Pick any 2 points you want from that graph that aren't on that line. All right, so when we take a look here, we could pick any of them as long as it's not on the line, right? So I'm going to pick this one. This one is -2. -5 is mine. And then I'm going to pick the origin. All right, that's not on my line, so 0, 0 works as well. Okay. So what this is saying here is that, for instance, when I plug in 0 in for x, I get 6 as my output, which is why it's on the line. Here, when I plug in 1 into my equation for x, I get 4 as my output, which means 1, 4 is on the line. Okay? Here, if I were to plug in 0 for x, I get 6, which is why 0, 0 is not on the line. Okay, so that's something to think about. So when we're looking at 3, it says, given y equals 2x plus 1, would the point 3, 2 lie on the function? Would the point 10, 21 lie on the function? Well, what we could do is we could graph this and see if those points lie on it. But I mean, these are some kind of relatively high numbers in retrospect to what we're dealing with. So instead, why don't we write y equals 2x plus 1? And why don't we see if these work by taking the ordered pair x and y and seeing if it matches out. So this is saying that when I plug in 3 for x, I should get y equals 2. If it lied on the line, right? So here I have y equals, I'm plugging in 3 for x plus 1. Well, 3 times 2 is 6, plus 1 is 7. So this is telling me when I plug it into my function, when x is 3, y is 7. Well, 3, 7 does not match 3, 2, which means that this point does not lie on the function. So we're going to put 3, 2 does not lie on the function. Okay. Now let's check the point 10, 21. That means when x is 10, y is 21. So let's write our equation. Y equals 2x plus 1. So it's saying that when I plug in x being 10, which is what I'm doing right here, I'm replacing x with my 10, I should get 21 for y. So y equals, well, 2 times 10 is 20 plus 1 is 21. So this says when x is 10, y is 21. And it checks out, that point is true, which means that the point 10, 21 lies on this graph. So yes, 10, 21 is a point on the graph, right? All right, so looking at 4, it says, given the function y equals -3x minus 4, determine 2 points that lie on that function. Well, that means is I need to pick any 2 x values I want and find the y value that satisfies it when I plug it in. So for me, I am going to pick the point when x is 0, right? We know when x is 0, that's our y-intercept. So when x is 0, what is my y that matches it? Well, here it's -4. So 0, -4, I know is a point on my line. And the way I can check that is by taking y equals -3x minus 4 and plugging in 0 for x, seeing if I get that y is 4. So I have y equals -3 times 0 minus 4. Y equals, well, -3 times 0 is 0, minus 4 is there. So it's true, when x is 0, y is -4, so this is definitely a point on my line. Now the next easiest one I'm going to think of is when x is 1, what is y? So I have y equals -3x minus 4. So I'm going to plug in 1 for x and see what my y value ends up being on the line. So here I have y equals -3 times 1 minus 4. Negative 3 times 1 is negative 3 minus 4. Well, negative 3 minus 4 is negative 7. So negative 7 is on my line. Okay. Now, because it's a line, right, if we look up here at this one, for example, when x is 1, there's only one y value, right? There's only one point that we get right here, which is really important because that tells us that any other point with an x value of 1 that does not have a y value of 4 will not satisfy my line, right? It will never be a point on the line. 1, 2 will never be a point on this line. 1, negative 5 will never be a point on this line because it crosses exactly at 4 for the y. So when we determine 2 points that do not lie on the function, then we can look and see here that 0 and any other number but negative 4 will not lie on the function. So I'm going to say 0, 3 will not lie on the function, right? Because 0 is already taken, because when I plug in 0, I get negative 4. There's no way here I can plug in 0 and get negative 3. Next point I'm going to pick is 1 and anything but negative 7 because I know that is a point on the line. So I'm going to pick 1, 5. Could you pick 1, 8? Of course. Could you pick 1, 7? Of course, as long as it's just not negative 7 because that is the point on the line. Okay? So looking at 5, it says which point is a solution of 3y plus 4x equals 12? Well, that means as well, which point is on the line that this creates? And the easiest way to do this first is to get y all by itself. Okay? So we're going to have y equals something. Well, first, we have to subtract this 4x that's being added to it to get it by itself. So I'm left with 3y equals 12 minus 4x. Right, and then I need to divide each of these by 3. So I'm going to divide by 3, divide by 3, divide by 3 to get y all by itself. So I'm left with y equals, well, 12 divided by 3 is 4 minus 4/3 x. So now I need to plug in values of x and y to see if this satisfies, to see if it's on my line. So here, this says x is 3 and y is 0. So looking at this, I have to plug in x equals 3, y equals 0, and see if it works. So here I have y equals 4 minus 4/3 x. So we have 0 equals 4 minus 4/3 3. If this is true, then I know it's a point on my line. Well, 4/3 times 3 is the same thing as dividing by 3 and then multiplying by 4. So these cancel out, and I'm left with 0 equals 4 minus 4. Well, 4 minus 4 is 0, so because it works, that's a really good contender for being a point on my line. Right? If we looked at 2, 2 says when x is 8, y is 2. So let's see if that works with this. I'm going to do the work over here. Okay? So I have x is 8, y is 2. So I have 2 equals 4 minus 4/3 times, we have, my x value is 8. Well, 8 times 4 is 32 divided by 3. There's no way 4 minus 32 over 3 is going to give me 2. So that's out of the question. And you can do the same process for the next two to see that 1 is our correct answer. When we plug in that x value and that y value, we get that satisfies, which means we know it's a point on our line. Okay? So looking at this next one, number 6, it says, which of the following lines does the point 3, 6 lie on? Note there may be more than one. So what this means, remember, is that when x is 3, y is 6. Is this true? Well, let's find out. So for the first one, y equals, we have our x value that we have is 3. right? So we have 3 plus 2. Well, 3 plus 2 is 5. I am looking for a y value of 6. This is a y value of 5. So I know that's not a point on the line because instead I know that the point 3, 5 lies on the line because that's what satisfies the equation. So this next one, y equals, I'm plugging in 3 for x plus 3, y equals 6. Well, yeah, y equals 6, that's perfect, right? That tells me that when x is 3, y is 6, and that is something that I'm looking for. Next one, same idea. I have y equals 2 times 3, which is our x. Well, 2 times 3 is 6. So that means that when x is 3, y is 6. And that means that I'm good to go because that's the point that I was looking for. This next one, when I plug in 3 for x, I get y equals 3 times 3, which is 9. Uh-oh. That means that when I plug in 3 for my x value, I get 9 for my y. That's not what I'm looking for. So that is not a point on that line. Next one, I have y equals 3 plus 5 because 3 is my x value. 3 plus 5 is 8. That's certainly not the 6 I was looking for. So because the point 3, 8 lies on this line, there's no way 3, 6 can lie on it as well. Last one, y equals 4 times 3 minus 6. Well, 4 times 3 is 12, minus 6 is 6. So that means when x is 3, y is 6, which is true, what I was looking for, which means that these are the 3 lines that have the point 36 on them. Pretty cool, huh? All right, so now looking at 7, we have a linear equation passes through the point 2, 7 with a slope of m equals 6. It says write the equation of the line and determine if the point 1, 1 lies on it. So we got to backtrack a little bit, right? We need to take this point and this slope and create the point slope equation. So we have y equals mx plus b, remember. So remember, when we're doing this, we have x equals 2, y equals 7, and m equals 6. So I'm going to plug all of these in here. So I have 7 equals 6 times 2 plus b. Because I want to solve for b, remember, so that I can write this equation with my slope and my y-intercept. So I have 7 equals 12 plus b. Subtract 7 from 12 from both sides, I'm sorry. And we get that b equals, well, 7 minus 12 is negative 5. Okay, so now that I have my b and I have my m, I can write my equation, y equals 6x minus 5. Y equals mx plus b. Okay, now from there, it wants to know if this point lies on it. So since this is the equation of my line and I want to see if this point lies on it, that means that I hope that when I plug in 1 for x, I should get 1 for y. So let's see. Y equals 6 times 1 minus 5. Well, y equals 6 times 1 is 6, minus 5 is 1. So when x is 1, y is 1. Is that the point we were looking for? Yes, it was. So does this point lie on the line? Yes, the point 1, 1 lies on y equals 6x minus 5. Okay, so now what I would like you to do is take a moment to do 8 for me. 8's a little bit different because it wants us to find a point, it wants us to find the equation that passes through these 2 points. So remember, you're going to have to set up your table first to find your slope and your y-intercept. Then from there, you're going to have to do the new step where you have to see if this point is on the function and how do you know. Okay, so go ahead and take a moment, pause, and do number 8 for me, please. All right, welcome back. So taking a look at 9, we're given 2 points again. And we want to determine one more point that lies on the function and one point that does not lie on the function. This one's going to be a little bit more difficult. I want you to try the best you can with it. You know how to find the equation of this line. Do that first, and then think to yourself, what's my y-intercept? What's something that's not my y-intercept? And those will give you some of the ideas for the points that are on the line and that are not. Okay? All right, welcome back. Let's take a look at 10. So 10 says the points 2, -2, and -4, 13 lie on the graph of a linear function of x. Which point also lies on the graph of this function? So with this, what I would do is find the equation of my line. So I have 2, -2, -4, 13. Find the equation of my line. I'm going to have to do the change in y over the change in x to find my slope. Find my y-intercept. Then when you're done, I would take each of these points and plug them into your function to see if it's true. Okay, so go ahead and take a moment to do that for 10. When you're done, please get it checked, and then you can do the same thing for 11. Have fun.